Hello everybody. In this question, the sum to infinity of a geometric series is 96, and the first term of the series is less than 30. The second term of the series is 18. So we need to find the first term and the common ratio of the series, and then we show that the nth term of the series un can be written as un is 3 to the power n divided by 2 to the power 2n minus 5, and hence show that log to the base 3 un equals n times 1 minus 2 log to the base 3 2 plus 5 log to the base 3 2. So let's start with the first bit. So what we need to do is to find the first term and the common ratio. So we're given the sum to infinity, the geometric series. So suppose a is the first term, so let a be the first term and r be the common ratio. So then we can write the sum to infinity. The sum to infinity is given by a over 1 minus r. So in this case, a is the first term, as always, and r is the common ratio. So this is given as 96 in this case. So I can then write, I have, no, we don't have a, so the first term is less than 30. So the second term is 18. So then I can write r as equal to 18 over a. So then substituting that in the equation for sum to infinity, we can write a over 1 minus 18 over a is equal to 96. And then I can write a square over a minus 18 is equal to 96, and I can say therefore a square equals 96a minus 96 times 18, and that is equal to 1728. So therefore I can write a square minus 96a plus 1728 is equal to 0. So therefore a equals minus b, so minus of minus 96 plus n minus square root of b square, so that's minus 96 square minus 4ac, 4 times 1 times 1728, that is over 2. So then we should get two values of a, so I can write therefore a equals 96, so it's either plus square root of, so that's this expression, this term under the root, so that would work out to 2304. So that's 2304, so 96 plus 2304 over 2, or a equals 96 minus square root of 2304 over 2. So 2304 is a perfect square, and the square root of 2304 is 2304. So that's 48. So then I can write A equals, so this would equal 96 plus 48 over 2, or 96 minus 48 over 2. So then obviously this result is going to be greater than 30. 96 plus 48 is 72, and that is greater than 30. So we are interested in this result because that is equal to 24 as less than 30, and therefore A is equal to 24. So once we know that A is 24, so I can then say that A is 24. So if A is 24, then I can work out what R is. So therefore R is 18 over 24, and that is 6 times 3, of course it's 3 over 4. So A we found out, and R is 3 over 4. So that's the first part completed. Now for the next bit, so my apologies, it's can we can forward the video to save time to make it too long. So the second bit is we need to show that the nth term of the series un, so that's what it is, that the nth term of the series un can be written as un is equal to 3 to the power n divided by 2 to the power 2n minus 5. So we need to work on it. So we are given A we now know, R we know. So the nth term, so un can be written as A to the power R minus AR to the power n minus 1. Sorry. So the first term is 24 times R is 3 over 4 to the power n minus 1. That's the nth term. So we have to somehow bring it into this format. So then I can write 24 as 2 times, so only 2 and 3 are allowed, so as multiples of 2 and 3, so 2 times 2 is 4, times 2 is 8, times 3 is 24, and then times 3 to the power n minus 1, and the whole thing divided by 4 to the power n minus 1. So I can write this as 2 cube times 3 to the power n over 4 is can be written as 2 square. So 2 square to the power n minus 1, and that is equal to, I can keep 3 to the power n in the numerator and bring this 2 cube down, so it will be 2 to the power minus 3, and multiplied by 2 to the power 2n minus 2. So hence I can write this as 3 to the power n over 2 to the power 2n minus 5, and that's exactly what uh, we need to show the nth term of the series is equal to. That's done. So now we need to work on the next bit, is where we have to bring in logarithms. So again, I'm going to erase this. Sorry for using the eraser this way. I'm not deleting it because I don't have the keyboard. So then what I can do is, we are working on this third part, so hence we show that this. So what we're going to do is, if we're given, so I'm going to write it again. So un is equal to 3 to the power n over 2 to the power 2n minus 5. So taking log to the base 3, if you notice, it's log to the base 3. So the main question, it's log to the base 3, log to the base 3, log to the base 3. So so if it is log to the base 3, so we have to take log to the base 3 on both sides. So I'm going to say taking logarithm of both sides or on both sides. So that's log to the base 3. So then we can say log to the base 3 un is equal to log to the base 3, 3 to the power n over 2 to the power 2n minus 5. So log a over b is log a minus log b. So left hand side remains as it is. So that's what it is. So no problem there. So log to the base 3 un is equal to log to the base 3, 3 to the power n minus log to the base 3, 2 to the power 2n minus 5. So then I can rewrite this as equal to n log 3, 3 minus 2n minus 5 log to the base 3, 2. So log to the base 3, 3 is 1. So that is equal to n minus 2n log to the base 3, 2. Minus and minus make a plus 5 log to the base 3, 2. Okay, so I'm nearly there. So what I can then write is that is equal to take n outside the bracket 1 minus 2 log to the base 3, 2 plus 5 log to the base 3, 2, and this is equal to hence un, and that's my proof completed. So we've shown that this is true.